this is Charlene. We're talking about factoring radical expressions in this video. This is a radical, this is a radical, and there is a subtraction sign between them. So because we have two radicals joined by a subtraction sign, that is an expression. So we need to think about the fact that factoring expressions are about pulling the expression apart into all of its pieces. And in the final analysis, we should have only the simplest expressions multiplied times each other, because that's what factors do. Factors multiply times each other. It's just like 3 times 4 is equal to 12. 3 and 4 are considered factors of 12 because they are the two simplest numbers that will multiply, or two of the simplest numbers that will multiply to equal 12. So we're going to look at breaking these down. I'm going to look at this one first. So let's go ahead and just pull it apart here. So I can pull all this apart. We've got to understand that this is like the fifth root of 96, and that's times the fifth root of x, and that's times the fifth root of y. Okay, so we can, because multiplication is commutative, that's the reason why we can pull all those things apart into their pieces. It's just like if we have 12, we can break it apart into 3 times 2 times 2. We can break that apart, and it doesn't make any difference. This is still equal to this. So this is still equal to this. So hopefully that makes sense. But let's go ahead and start looking at what we've pulled apart. Okay, so the first thing that I should notice is that and I didn't write this down. This is actually the fifth root of y to the fifth. Well, the fifth root of y to the fifth is just y. Because if you think about it, it's like the fifth root of y times y times y times y times y. And so there are 1, 2, 3, 4, 5 factors of y. And so therefore it comes out. 1y comes out to represent all 5 of the factors of y. So the fifth root of y is equal to y. Okay, so let's get rid of that so we can continue to think about the pieces and parts. Okay, so this next section right here is the fifth root of just a single x. So there are not 5 factors of x there. There's really, at this point, there's nothing that we can do with that. So we're just going to leave that alone. So that's going to remain fifth root of x. But this is going to become the fifth root of y to the fifth is just a y. Okay, now we've got to consider this little hairy looking radical. So again, scratch paper is your friend when it comes to problems like this, because I need to look at the fifth root of 96. The fifth root of 96, it's not a nice, neat number. It's going to be a messy decimal number, which means I need to break down that 96 into all kinds of little factors to see if I can find 5 of any one factor. So I'm going to break that down into 2 times 48, and then I'll keep breaking it down. So 2 times 2 times 24, and then 2 times 2 times 2 times 12. And if you notice, this is still equal to this, is still equal to this, and let's keep breaking it down. So 2 times 2 times 2 times 2 times 6. Well, I've got 1, 2, 3, 4 factors of 2, but I'm looking for 5. So if I break it down one more time, 2 times 2 times 2 times 2 times 2 times 3. So now I have arrived at 5 factors of 2. That means that one of those 2's can come out to represent all 5 of those. So again, this is the fifth root of all of this. One of those 2's comes out to represent the 5 2's. And so that means that the fifth root of 96 is going to be equal to a 2 times the fifth root of whatever has to stay in the house. Well, what's staying in the house? Well, my loosey-goosey 3, it's all by its lonesome. It is going to stay in the house. So that means that this fifth root of 96 is going to be equal to 2 times the fifth root of 3. Okay, so as of right now, this right here at the moment is equal to this. Okay, so now we need to consider this radical. Okay, so we're going to have to break this second term down into its pieces. The y is just there by itself, so we're just going to go ahead and bring it down. I can't break down the y any more than it is, but I do need to look at this fifth root of 3,072. Technically, there's an x with it. Okay, and that's a big number, so we're going to go ahead and pull up our calculator. And 72, factors of 72, 8 times 9. So I'm going to see if 8 or 9 fits into that, because 72, 8 times 9 is 72. So let's see if 8 fits into it. So 3,072 divided by 8. It does fit evenly. So let's use 8 times 384 as our starting place. Okay, so our fifth root of 8 times 384, and then there's an x there. Okay, let's go ahead and use our calculator one more time. 84. Factors of 84, like 7 and 12, so 384 divided by 7. Nope, that doesn't work. 384 divided by 12. That does work. So 12 times 32, I can break that down. So we got 8 times 12 times 32. And then the x is still over there. Okay, I'm going to keep breaking it down because I'm still looking for 5 roots. So 8, what does 8 break down into? 8 breaks down into 2 times 2 times 2. So there's 3 of them. And then 12 breaks down into 2 times 2 times 3. Okay, but 32 can also break down. So we're going to break down just 32 over here. If you happen to remember, if you're dealing with these numbers a lot, 2 to the 5th power, I believe, actually is equal to 32. So let's pull that up in our calculator. So 2 raised to the 5th power, it is equal to 32. So that means 32 is also 2 to the 5th power, which would be 5 times 5 times 5 times 5 times 5. Okay, so that means that all of this is the fifth root of all of these factors. Well, right there are 5 2's. So that means one of these 2's comes out to represent all 5 of those factors. And this is also going to come out. The fifth root of 2 to the 5th is also 2. And then we would multiply these two numbers back together. But there's one number that's loosey-goosey. This one right here is not accounted for, and it is going to have to stay in the house. So I'm going to multiply the 2 times 2 that came out of the house, which is going to be equal to 4. And that's going to be 4 times the fifth root of the one number that's going to stay in the house, and that's 3. So that means that the fifth root of 3072x is going to be equal to 4 times the fifth root of 3x. Can't forget that x that was there. Okay? So now let's go ahead and erase our scratch area. Okay, so, oops. So we're going to go ahead and have y is equal to 4 times the fifth root of 3x. Okay, let's go ahead and bring all that down. All that down. Okay. And minus. So again, we've got just to remember that this is still equivalent to this. They're still equal. They just look different, but they represent the same values still. So now we've got this term and we've got this term. Can we more clearly see what both of those terms have in common? Well, they both have a y in common. So that means that I can pull a y out. And they also both have a 2 in common. So that means I can pull a 2 out. Now, if you're paying attention, this piece right here, and this piece right here are actually identical. The fifth root of x, the fifth root of x. So that means I really can put it back under the radical. Okay, so I'm pulling that out. Like I said, it is a little bit hairy to think about all this stuff, but it's a lot of moving parts, but you can do it. So 2 comes out, and then I'm going to end up with the fifth root of 3. That's what's left. The 2 came out. I've left with the fifth root of 3. The fifth root of 3. Fifth root of 3. And then I've got the fifth root of x. The y came out. And then over here, a 2 came out. And a y came out. So like the 4 becomes a 2. 2 came out, but 2 is left. The y came out. There's the y. And that's times the fifth root of 3x. And we've got to kind of realize that these two things can be put back together. We are allowed to multiply under the radical. So that means that would turn into 2y. And I'm going to multiply 3 and x back under the radical. So fifth root of 3x minus 2y times 2 times the fifth root of 3x. Okay, and we're going to scroll down a little bit to finish this up. So now, what does both, okay, now we have two expressions again. We have this expression right there. We have this expression right here. What does both of them have in common that I can factor out? It's a 2y and a 2y. So I'm going to pull that out. So it's going to be 2y comes out, and what's left is the fifth root of 3x minus 2 times the fifth root of 3x. And let's see, forgot that little parentheses right there. Okay, so, and now we can actually subtract these two things. So, because this is actually a 1 invisible 1, so 1 times the fifth root of 3x minus 2 times the fifth root of 3x. So that's going to be 2y, and that's going to be negative, invisible 1 times the fifth root of 3x. But I can bring this negative out front. So my final answer is going to be negative 2y times the fifth root of 3x. I know that's kind of a long, drawn out process, but if you just kind of think about it logically, you try to keep things kind of lined up, I think you can do it. Just needs a little practice. Okay, you have a great day, and we'll see you back the next time.